Hello everybody, it's a pleasure to be with you here today. My name is Martin Huber and I am the CEO at Metaroom by Emrex, representing a pioneering scan-to-BIM solution based on smartphone LiDAR technology. Today we are looking at a very exciting topic, scan-to-BIM in the context of lighting design. First, we will look at the challenges surrounding data and how BIM differs from other data. If we look at building data in general, we realize that we have almost none. It's different for new buildings, but the majority of existing buildings still need data that we can use for lighting design. At the same time, the demand for such plans is very high and constantly increasing. This is mainly because we are dealing more and more with energy efficiency. 60% of electric consumption arises from buildings, and depending on the type of building, a large proportion also comes from light energy. In addition, we also consume a lot of energy via wireless networks, which is usually completely invisible and unrecognized by us. 3D plans help us enormously in understanding and simulating these energy consumers. So we can see this 3D data from buildings can be highly useful, not only for lighting, but also for many other areas, such as wireless network planning, facility management, and of course, various interior design applications. Before we delve deeper into BIM and 3D capture, I would like to briefly discuss the distinction between BIM and other 3D data. I think it helps with the further understanding and it also creates a focus. Let's take a close look at BIM. Here we see at the top of the list of advantages that we are standardized, which is also the biggest advantage of all. Work has been underway to standardize BIM since 1997, and the latest version, IFC 4.3, has been official ISO standard since 2nd April 2024, making it the global standard. The second item on the list is collaboration, which has many more positive effects, such as reducing errors and optimizing processes. And of course, this also pays off in terms of financial aspects. BIM literally saves money. Now, let's jump to one of the most important aspects, opportunities and challenges. As every new technology also comes with both sides of the medal. I think everyone knows such images, lots of icons, complex software. Almost every 3D process today is in extreme need of training and requires experts. The software packages can do almost everything. But can we do as much? I once saw a study that we use an average of 2 to 4% of the features that Microsoft Word offers. I don't think it will be much different here. But sometimes you need just that one special feature. We can also see that AI is also making its way into the field of buildings. And of course, into the field of lighting and lighting design. It feels a bit like so much is happening in the AI sector that we as humans can barely keep up. In the picture on the right, you can see a curve that I really like. But the good thing is that AI not only makes things better, it also can make them easier. In addition to large language models, I think everyone will have heard about ChatGPT. A lot has also happened in the field of machine vision. AI in the recognition of objects, but also in the estimation of depth, in other words, the third dimension, has been around for much longer. You can imagine what I'm about to show you as the autopilot of a state-of-the-art vehicle only on a cell phone. The app I'm showing you now, Metaroom, can be downloaded for free on the App Store. So you can also give it a try on your own. Let's start a new scan together. Right at the start, the system automatically recognizes walls, windows, tables, chairs. A total of 16 classes of objects. However, much more information is calculated in the background, such as the reflectance of walls, which plays a major role in lighting design. Typically, a scan of one room takes around 2 to 3 minutes. There is no training necessary, but a bit of experience helps, like doing a couple of scans before we go out in the wild. We also record the 4 positions where existing luminaires are located. We can already see this in the overview, displayed as green icons. Now we have successfully digitized one room. Basically, it can be said that there are no hard limits for the size of the recordings. It can be used to record entire floors and buildings. Now we jump into Metaroom Studio and take a look at the scan we have made together. Here, it is now possible to add more objects to rooms. We remember the additional recordings we made of the ceiling. With these additional recordings, the so-called points of interest, we can now generate the exact positions of the luminaires. Furthermore, we can assign the room usage type. We can see that a room assignment has already been made fully automatically. If we are happy now, we can export it. That's what we are doing now. And now we open the automatically generated file in lighting design software, Relux Desktop in this case. So now we opened the exported file inside Relux Desktop software, and we can see this is not only geometry, it is an intelligently created room, including the evaluation areas, also the reflectance of the walls, and all the objects we can see here on the left side in the model tree. Also the additional ceiling position, what we generated inside Metaroom Studio, can be seen inside Relux. And from here, we can just click on Calculate, and we can see that without any further manual adaptation, this BIM model, which has been created with the app, can be used natively inside light planning software to generate us a first calculation result. And here, the circle closes with the AI possibilities. In this case, we have not only experienced a new way, but also an enormous simplification. We no longer need expert systems to record a parametric model. In terms of accuracy, we end up with a system like this at around 5 centimeters, which can be seen as a disadvantage here, but in our experience, this does not play a major role in the field of lighting design. I would like to finish with a beautiful project of ours, here near Salzburg. The property is called Ziegelstadel and is a very old building that was to be equipped with new light. The hall has a total length of 60 meters and a width of 25 meters. The scan took a total of 30 minutes. The windows, doors, staircases, and also the existing luminaires were digitized. The data was then transferred to the Relux Desktop software, where it was calculated and run through in the new real-time renderer. Now it only remains for me to thank you all for watching and listening. Let's make the world more efficient together through digitalization. All the best from Salzburg, and feel free to contact us if you have any further questions.